Hello everyone. Thank you so much for joining us today. My name is Vijay Injam. I have my colleague here, Mahi Gunturu. Together, we are delighted to present today's topic, which is building microservice applications with Amazon MemoryDB. Many people ask me what is Amazon MemoryDB to begin with, right? So Amazon MemoryDB is a newer database service in our in-memory database portfolio here at AWS. For the next 20 minutes or so, I'll be talking about what is Amazon MemoryDB for Redis and providing you the value proposition of the service in building microservice architecture. And my colleague Mahi will help us understand the general best practices in building microservices and also how MemoryDB will be helpful in building this microservice architecture. And also, we do have a sample retail application built completely on the microservice architecture. I'm going to show what are the advantages of building that particular application using MemoryDB for Redis. And also, that is just a concept. However, using those concepts, you can actually build any kind of microservice architecture using the service. And also, this is a chalk talk. So towards the end of the session, we'll be open for the Q&A. And please feel free to ask us any questions. We're happy to do whiteboarding for you and clear any doubts you may have. OK, to begin with, what is Amazon MemoryDB for Redis? So Amazon MemoryDB for Redis is an in-memory database which has a Redis which is compatible with the Redis APIs and which provides ultra-fast response time. Let's unpack that a little bit. So if you're using Amazon MemoryDB for Redis, 100% of your application data will be in memory. So we all know that the memory is a few hundred times faster than SSDs, right? So your application will get ultra-fast response time. And we are talking about microseconds latencies for the reads and also milliseconds latencies for the writes. In later slides, I'm going to talk about how we can achieve those things like that. And if you're building an application, chances are that you'll be already using data structures like sets, dictionaries, sorted sets, things like that. And using Redis APIs, you can actually bring those data structures directly to MemoryDB. You can interact with MemoryDB, store your data in MemoryDB, interact with it, things like that. And if you're already building your application with Redis APIs, you can almost do a lift and shift because the service is compatible with the Redis APIs. And the service is 100% durable. A lot of our customers ask, like, if a database is built completely on top of memory, how can it be durable? So this we do have something called multi-AZ transaction log, which is a AWS innovation. It supports the durability and also consistency part of it. And I'm going to talk a little bit more details of that in later slides. And the service is fully managed service. So we can work with you to build the cluster that you want to build, you want for your application. Once the cluster is built, we can take care of the managing part of it, upgrade, OS patches or service upgrades, things like that. We can take care of all of those things for you. And the service is fully scalable, which means as in your application grows, the service itself can be scalable up to 100 terabytes or 400 total nodes, whichever comes first. And the service is fully secure. At AWS, security is our high priority, and we ask our customers to build VPC following the best practices that we put forward, and we'll use the VPCs to deploy the cluster. But within the service, the communication between node to node and also the data at rest is fully encrypted. So these are the top features of the service. In the next few slides, I'm going to concentrate my talk specifically on the top features. Okay. So what you're seeing in the screen right now is our simplistic deployment of the service. So you can see in one shot, we have one primary and two replicas. And the cache nodes is what we call these nodes deployed across multiple availability zones within a given region, right? So once we do that, another important feature is the service comes with, like I said, a feature called multi-AZ transaction log. As the name suggests, this is a solution that spans across multiple AZs within a given region, right? And let's say if if client's application connects to the cluster, it connects to the primary node, and we'll see. And this connection is technically asynchronous in nature. And let's see how it works. If a client sends a request to the cluster, obviously the primary gets the request, write itself, and it forwards the request to the multi-AZ transaction log in the same AZ, right? Then The multi-AZ transaction log in the same AZ forwards the request to the other multi-AZ transaction logs in other regions. Once the multi-AZ transaction log, in this example, in the zone B, receives the acknowledgement back from the other multi-AZ transaction logs, it forwards the request back to the primary with an acknowledgement, right? And now the primary, after receiving the acknowledgement back from the multi-AZ transaction log, it responds back to the client with an acknowledgement. So if you look at here, right, if a client sends a request to the cluster, before the client gets an acknowledgement back, the data is written in the primary node and also in multi-AZ transaction log, right? And multi-AZ transaction log is on-disk solution. Because the data is made it through that and gets acknowledgement after it made it to that, the data is 100% durable, right? In any given scenario, the data is 100% durable. And another point is, the data in the primary is going to sit in the memory. And we all know that memory is really fast. So all the reads that's going to happen from the primary is going to be super fast. I'm going to talk about the numbers in our internal test in later slides. Now, multi-AZ transaction log takes care of hydrating the data to the replicas, right? It takes care, it owns that part. So what you had seen in the screen right now is a simplistic approach of how the data made it to the primary, multi-AZ transaction log, and the replicas. So this is the durability, and as you can see, the multi-AZ transaction log made it possible to provide the durability for the service, right? Now let's look at the consistency part of it, how the consistency plays around within the service. Before that, let's look at the whole data flow, how it works. So client sends a request, primary sends forward the request to multi-AZ transaction log, and multi-AZ transaction log responds back to the primary, and clients get acknowledgement, right? Following that, multi-AZ transaction log forwards the request to the replicas. Okay, this is the happy path, right? So at this scenario, since you're connecting to the primary and getting response back, your data is always consistent, right? Because there's only one primary node you're interacting with. Now think of a scenario. What happens if the primary goes down? Are we still going to provide you the consistent data? And again, when I'm talking about consistency, what I'm talking about is, in any given scenario, we want to provide a consistent view of the write, or consistent view of the data in ideal scenario like this, or in an event like a failure happened to the primary. So let's look at that. And to explain that concept, I'm gonna use two different tools here. On the right hand side, you can see I'm calling it as time scale. The time goes from the current time is t, and t1, t2, t3, like that. And also I'm going to use the pointers, right? You can see a pointer at the primary. On the right hand side, you can see the replica 2, and left hand side you can see replica 1. I'm going to use these pointers and use the time scale to explain you at any given point of time what is the data freshness, right? I'm going to do that. So again, I'm going to talk about the very simple scenario of in scenario 1. Client sends response to the primary. We already know this. Multi-AZ transaction log gives the acknowledgement back to the primary. And at this time, we know data made it to the primary and multi-AZ transaction log, 2 places, right? If I want to see the data freshness at the time, they both have the 100% all the data is persistent in primary and multi-AZ transaction log in 2 places, right? That's why both these pointers are showing at time t, correct? Now, again, the scenario continues. Multi-AZ transaction log transfers or hydrates the data to replicas. So if I look at the data freshness for my whole cluster, including the primaries and replicas, this is how it's gonna look like. All of the data made it to all the nodes, right? Every single node has this data. This is a ideal scenario, right? This is a normal scenario, I should say. But there could be some scenarios where data cannot made it to one or other replicas, right? Let's look at the scenario. So now, we know the drill. We just follow the first part. Multi-AZ transaction log gets acknowledgement from the other multi-AZ transaction log from other availability zones. It gives response back. And now, look at the replica 2 on the right-hand side. Some data did not made it to the replica, right? This can happen in many scenarios. For example, there could be the network congestion happening in that particular area, or that replica could be busy doing something else, right? It can happen in scenarios like this. If I want to look at my data freshness at this stage, this is how it's going to look like. Multi-AZ transaction log primary, again, they are always in sync. and replica 1, which is on the left-hand side, is also synced because all the data made it to that. Now, replica 2, we can clearly see some data did not made it to the replica 2. So that's why you can see replica 2 is 3 seconds behind, right? Now, same. Let's look at the third scenario. We know the drill here. Let's wait what this scenario will show us, right? Data goes to multi-agent transaction log. Now, client's getting the acknowledgement back. Multi-agent transaction log is going to hydrate the replicas. You can see that this can also happen in some cases where data is not made it to even the second replica, right? So again, data is always there in primary and multi-agent transaction log. If I see now what happens, your replica 1 on the left-hand side, it has just a little bit of data that's missed. So it is 2 seconds behind. And replica 2 on right-hand one, there's a lot of data missing there. So it is 6 seconds behind, right? So again, at this stage, how can we achieve fully consistency for your application? So at this stage, let's say if primary goes down, multi-agent transaction log looks at what is the current timestamp for its latest data, right? That's what the purple box shows. So the current timestamp is obviously a T, right? Then it checks what are my available replicas and what are the timestamps. It checks that. So the available replica closer to the primary is obviously replica 1, which is on left-hand side, right? That is the 2 seconds behind. Now, multi-agent transaction log takes the responsibility of hydrating that missing data, which we call it as rollups, and stream the data from multi-agent transaction log. And again, this is a disk-based system, right? It's once client get acknowledgement back, data is always there, right? We already established that. So you can see, if you can see the left-hand side one, so the data will be hydrated, the missing data. Then multi-agent transaction log do another check so that it will know that particular replica is up to date in terms of data freshness with the primary and also itself technically. Then if you can see the left-hand side one, it switches that replica to the primary. At that point, your client can establish the connection again, all right? So because of this multi-agent transaction log feature, the service is fully consistent, fully durable in the first place, and also fully consistent. So at any given point of time, the clients will get the same consistent data regardless of any scenario. And I already mentioned that the data is 100% in memory, right? That's why it's super fast in accessing things like that. So this is how the solution provides, again, durability and consistency. Now let's look at some numbers. And I also mentioned that the data in the service is 100% in the memory, right? So if clients can interact with the service with any kind of services, for example, the application could be in EC2s, Forget, Lambda, anything like that. And the service has something called configuration endpoint. It connects to that. And the numbers we are seeing for write specifically is single-digit milliseconds. And again, that's because the data is making it to the multi-agent transaction log, which is a disk-based system, right? Because of that, the performance we are seeing for the writes is still is really fast, single-digit milliseconds. And with our internal tests, and this is consistently we're seeing from customers as well, for a single R6G 16x node, we're seeing 100K writes per second. And also, it's also showing us that 100 megabytes per second, right? This is the write performance or write throughput we are getting with the service. And in terms of reads, again, when clients connecting to the cluster, all the data is available in memory. So we are talking about super fast response times. So the read performance we're seeing is, it's actually single-digit microsecond latencies. The service can provide 360K reads per second or 1.3 GB throughput per second, right? So the service is super fast and super durable as well. Even it is fast in many sense for even writes, right? We're talking about single-digit milliseconds for writes, but reads, it is microseconds. And the service is extremely scalable. Like I mentioned, the cluster if you build a cluster, it can be scaled up to 100 terabytes or 400 total data nodes altogether. Okay, so what are the common use cases we are seeing across the board? So it really comes down to any service that needs ultra fast response time, right? That is a single most use case. And also because of the fast response and also durability, a lot of customers actually use this service as a primary database. They're actually like in some cases, customers may have a persistent database and also a cache for fast response. But with MemoryDB, you can actually simplify your architecture by removing the cache and database and use one MemoryDB itself, right? And we are seeing this across many industries. One of our fastest growing industries is retail. Up until now, I should say finance. Up until now, there is, even for Redis, if I'm talking about Redis, it's very low adaptation for finance customers because they want 100% durable and consistent data. But with this, we are seeing a lot of improvement, a lot of customers from finance actually using the service. And apart from that, we see a lot of web and mobile applications, gaming use cases. And IoT is a newer sector we are seeing. Again, we're talking about millions of reads and writes, and I already showed the throughput numbers, things like that, right? So we're seeing a lot of interest from the retail use cases and IoT use cases as well. And obviously media and entertainment. And for today's talk, we're gonna restrict our talk specifically to retail use case. And we're gonna show you a application that built on MemoryDB, and the application is completely built by using microservices. And when we are talking to our customers, a lot of our customers point out 2 or 3 main important factors, right? For example, a lot of customers start building their microservices in a very small scale. Very soon, they may have to add more, they may need to add more services or more use cases. Yeah, over time, their smaller infrastructure may actually grow over time, right? And when we're talking about microservices, it is very common that one service interact with other service, and the total round trip for a call may actually has to go to multiple databases, things like that. So in microservices use cases, the performance is becoming really key, right? Because again, the more services you're interacting and things like that, every service talk to this, every service, and you're talking about higher latency between the services. That's one common use case we're seeing. And then the second use case is, again, it falls under the same category, which is if I'm building a microservice, I'll start with one use case. And as soon as I'm adding another use case, in general philosophy of microservices, share nothing architecture, things like that, right? You have your own stack, your database, things like that. But when you're adding more, a lot of customers actually creating another database or creating another tech stack, things like that. And they're increasing the footprint of the service, and also they have to find new talent to support this new service, right? So we're seeing things like that. So sometimes customers ask us, is there a database that can support multiple types of data representation, right? That's one of the common thing. And I touched upon this a little bit. MemoryDB is actually built on top of, is compatible with Redis. And I also talked about the data structures that Redis supports, right? Redis supports many variety of data structures. So with that, we are actually reducing the complexity of adding multiple different databases. So upon adding different complexity in managing things like that, right? So with Redis, you can represent your application in multiple ways because it supports multiple data structures, not just one data structure. So these are the main things we are seeing, and this is how MemoryDB can help building, this is how it can be suited as a better database for microservices. And my colleague here, Mahi, will help us walking through a retail app and then show us how the different data structures can be helpful in building the retail app. Mahi?
So let's start off with fairly simple things. What is a microservice? What we see in the industry basically is, folks are breaking down a monolith into multiple microservices. Usually, once you start dealing with a microservice, you take an independent domain and do maybe like some domain-driven design and just break it into a bunch of smaller microservices. And a lot of these microservices need to be loosely coupled. I mean, you need to have very loosely coupled but tight cohesion for some of these services. Each of these microservices are interacting with one another based on simple API calls and often it's REST APIs. You also want to make this independently testable and deployable. What you see with the monolith is like you put the whole system out there, and if it goes down, the entire system goes down. With the microservices-based approach, you basically can independently deploy, and you can independently scale them as well. What we also see with microservices, you sort of instrument your code with the proper sort of metrics. Then you can understand which part of your microservice stack you need to scale, so you can independently scale these. And you also have purpose-built tools. You want to use appropriate language for each of the microservice, which fits your developer skills. And also you want to, and AWS philosophy is also to use the appropriate database for the right application. So let's try to understand how MemoryDB is good for microservices. As Vijay briefly touched upon, with microservices, and as your user action results in a number of services interacting with each other, that results in a number of services being accessed as a part of a customer action. So for that, the latency budget is really important. You want to finish this as quickly as possible. So for that, you definitely need a purpose-built database like MemoryDB. Data needs very flexible and friendly APIs. We believe that Redis, with its really good list of data structures and APIs available, it really can support a lot of diverse actions for acting upon the data. And also with MemoryDB, we support a multi-easy transaction log, so each action is durable. So once your client gets an acknowledgement for your data, the data is durable. It's going to be there no matter what. I'll dive into a small application which we built for you today, where we have a small retail application where a user can simply log in, register and log in, browse a few products, click through a few products, and then order a product or two, and how that feeds into reporting and ordering and recommendations, which each one of them are a separate microservice. So each one of these are different microservices which support the business logic. And then based on the operational needs of it, you have other microservices which are supporting it as well. We use a variety of data structures for this. I'm just going to give a very quick primer on it. And for today, we're going to be touching mostly on the product and the recommendation service. So if you look at a product microservice, you get into the product, and you can simply add new products, delete new products. You can see product details, and all this data is stored durably in MemoryDB. You can use a hashed data structure for this. It's fairly simple. You use something like edge set, and then you set all the details for the product. And then you get a response back, and then you get if you want to get the data back, use something like edge get, and you pass the key and the field, and then you get the field and the values back. In this particular case, I just asked for a selling price, and it came back from 10.9. If you do an edge get all, it gets back all the data related to the particular key and the field and all the values of it. For the recommendations microservice, it returns back with some vendor names. A lot of it is prioritized or ranked based on the vendor and the appropriate product for the vendor. And all of this is being done using real-time streams. So we're using a real-time streaming API, and we're using a sorted set for doing some of this. So let's understand what a sorted set data structure is. You can use commands like zinker by to increase the appropriate value. Let's say somebody orders a infant formula, which is relatively difficult these days to get, I guess. So once you're accessing it, you just increase that, hey, a particular person has ordered an infant formula, and then you get a response back. And if you do a Z range, and you want to, let's say you want to order it or score it, and you want to score it reverse, so that the vendors with the highest orders getting fulfilled show on the top, and the vendors with the least show on the bottom. You would do something like z-range, vendor infant formula, plus infinity to minus infinity, or min to max. And then you would pass by score and rev if you want to do it in the reverse order. And then you would just limit it if you want the top two. You get back the results for that. And if you wanted to use a streaming data structure for doing this, Redis is becoming really powerful these days with streaming and the streaming data structures. So let me break down what a stream consists of. You would use something like xadd to add messages to a stream. So let's say you're passing hello to the stream. What it does, it generates a unique ID for this message, and then it appends messages to the stream. And then if you have a consumer from which you're consuming from the stream, just do xread or xrange or xrevrange or xrange in reverse order. And if your consumers are getting really CPU intense, because let's say you're using a particular, using it for a stream which has a lot of activity coming in, then you would want to spin up a consumer group. So all of this might sound very familiar with folks who are sort of plugged into the queuing or messaging ecosystem. So it's very consistent with those standard terminologies which are used by other queuing systems as well. So you would use X group and do a consumer group, and you can add more and more consumers in the consumer group, and each consumer group consistently gets the whole data, and till you do an exec where you're acknowledging the message, it's not removed from the pending entries list or PEL. Let's understand some of the commands which does this. Something like if you do xadd, it adds to the stream. You would pass the stream name and the value, and then you would create it. Then that comes back with a key, which gets automatically generated. And the -0 can deal with conflicts if there are any conflicts. The xread group can read from a group name, whatever group. In this case, we're calling order workers. And then you're passing a consumer name, which consumer is going to consume it. You can have multiple consumers or multiple consumer groups as well, and the streams and the key ID which you're looking for. So that's how and then once you get the message, you just acknowledge it, exec, so that it removes from the pending entries list, and that's it. You can consistently deal with data. The data is consistently dealt. You're not going to be losing any messages. It is delivered once, guaranteed once, and the data is durably stored in MemoryDB. And this is all you're fetching from MemoryDB using the same Redis API structures that you know. So at a point in time where it was very difficult to get data, consistent data from a distributed systems guaranteed once, we feel like we have really solved that concern. So putting it all together for the demo, which we're going to see in a little bit. So we have a registration workflow. All the data related to that is stored in hashes and strings. The product details are stored in a hash data structure. And all the user activity, whether it is interacting and clicking through some products and ordering a product, all of that activity is captured in a stream. And then we do some real-time sort of transformation of that data. And then we fetch that data out into a recommendation service or a shipment service or a reporting service. All of this is going to be done at extreme blazing fast speeds, single-digit millisecond for the writes and hundreds of microseconds for reads. Mm. So we're going to switch to a demo.
Yeah. Thanks, Mai. So, okay, how to get this? Okay, so I can also get to this real quick. Come on. Okay, well, this comes up. Let me walk you through this sample retail app that Mahi just explained us, right? Let me log in real quick. Okay, so like I mentioned, and also Mahi mentioned us that everything you're going to see in this app actually built on top of microservice architecture and purely using Redis data structures, right? You just saw I logged into the website, right? Obviously, I'm going to use the username, password, and also I'm going to use a profile, right? All of these different things we can store in Redis, either hash maps or simple sets. So in sets, basically, you can use user. Redis follows this key value pair notion, right? So you can use user and password to get a fast response time, just so that we can let the user log into the website. That's first thing. Or you can also, a lot of customers also use a hash table. So a hash table is another representation within Redis where you can create a view of a user and all his attributes in the same single view, right? That's a hash table. So you can use that. Let's say, again, I'm going to show you the data structures as well. But once I did that, I'm in the website, right? So there are, again, depending on how you're going to build your application, your value proposition, things like that, there will be multiple things you're going to build in your website, right? To get a user to enrich the user's experience. For example, here I'm showing I may have to create something like departments and multiple sections so that user can quickly go to the selected department or whatever the user is interested. So to do this, all I can do is create a key called, for example, here home and kitchen, and in home and kitchen is a key, and all the items in that will be my values. So I can use a data structure in Redis called sets. That's all. Set will be the home and kitchen will be the key. The values will be everything I'm going to show in this one. So you don't need to, for creating this particular user experience / category, you don't need to go for any other database, right? That's the point. And let's say once I'm there, what can I do with it? So I can actually search for different products, right? I'll go back to here, and let's say I'm picking this one. So I'm picking the skate, right? Skateboard. Riders skates. So for this, what type of data structure I should use? Again, I'll go back to the hash tables again. So with one hash table, I can store unique ID and also everything you're seeing here, right? This is what Mahi actually mentioned as well. I can store the price, the description, and also quantity of them available in my store, things like that. I can create the entire product view or product details using the hashes. Again, I don't need to go for any other database. That I can use the MemoryDB / Redis data structures available within the service to do this. And let's say I'm going to add few things, right? I'm going to add up to 5, add to cart. I'm going to look for the cart. Obviously, this is all happening in your website, in your browser, I should say. I can check out. Once I check out, again, I can see what are my orders, right? So again, I can either create the actual order based, if I want to show by user's perspective, I can either create a key value or sorted set. I can use multiple things, is what I'm saying. So for every different screen, I have a lot of flexibility to use MemoryDB data structures built on top of Redis to create my majority of my either screens or use cases, however, or business units you want to say. You can create multiple of them using this one database, right? That's the main point here. And also, I can create something called track your order. This is something we need to enhance a little bit more. But with MemoryDB for Redis, again, using Redis data structure, you can also create something called geospatial data structure. Suppose geospatial data structures where you can build a tracking system for your order, right? Like how far the order is, how many days within you can get it. So the main point is you can build multiple aspects of it using one database, and also, like I mentioned earlier, it supposes ultra fast response time, fully durable, fully consistent, and scalable up to 100 terabytes. So we have a lot of flexibility in building microservices using this. That's one point. And if I go back to one more thing and explain, based on adding on what Mahi mentioned, if I let's say this is very common, even at Amazon we do, and a lot of other customers do. Let's say if I want to enhance my user experience, right? So what I'm looking at it right now is I'm basically looking for balloons. And we always want our always want to recommend our customers what are the what are the relevant items that customer may be interested in, right? So traditionally, this was done based on like a badge job, right? For example, a lot of customers build their application based on, okay, how many items were sold, and if a user purchased an item, what are the other items the user purchased, things like that. They usually do for a overnight badge job, and then load it to the database, and then show it to the user, right? But in the newer way, we should do something better than that, right? We want to show the users that may like on real time. We want to come up with an ML-based algorithms that changes frequently, right? What happens if something happened, let's say a minute ago or 5 minutes ago, that customer may be interested in, right? We want to have this algorithms that builds to recommend something to the customer that may be based on the customer interest in the current purchase or prospect. Like we want to have a better ML model is what I'm saying. So how can we achieve this? So like Mahi mentioned, Redis does support this data structure called strings, right? So we can actually collect the click bytes or clicks that user is interested in. Like for every product page that user visiting, we can collect the clicks and put it in a stream, and then we can have a different microservice which actually looks for those streams, like look for those values, and build an ML model on top of it very, very fast and change these recommendations here, right? We can automatically update this. So you can actually give a user better experience or better shopping experience, and we can care our customers much better, and we can build all of these different aspects with the data structures and also with the service. And that's one of the primary reason we believe MemoryDB is a really, really good database for in general as a primary database, because it has all the aspects, but also more focused in building microservice architecture for this one. So let me also, sorry. Okay. So I'll just pick this stuff really quick.
Increase the font.
Okay. So I just logged into my service, right? The cluster. So I just use keys and star. So basically, everything you're seeing here is technically a different data structure, right? So this one is I'm showing my user profile, login, username login, and I stored my products. This is a hash map I'm using, and when I placed an order, like for example, so here this is the stream I'm talking about. Like in this example, let's say if a user placed an order, we want to create another microservice that looks for the order and does few things. For example, we want to create the shipment ticket as soon as possible that when the order is placed. And we want another microservice for look for the inventory, because that could be a very highly selling item for the day. We want something else for look for the item and place an order if the inventory is going low, things like that. We want multiple things to look for the order, that what's going on, things like that. So how can we bridge the gap for user interactive database, user interactive services versus the passive services or backend services like order or shipment? So we can bridge the gap between these two using the streams. That's what Mahi even mentioned. So every time you are placing an order, an event can go to the stream, and like I said, inventory or order can look for the stream and do whatever it has to do. So with one database, you can do multiple things. That's the main advantage of using MemoryDB for Redis. I can show a couple of other things. If not, because of the time, I'm gonna talk about our. We can switch back to presentation mode. I'm gonna talk about the value proposition that we can bring. So what are the ways you can get started or engage us, right? So if you're already building an application, and if you want to see if MemoryDB for Redis is a good fit for the database, or if you want to learn certain things, or you may be already doing some things and you want us to validate if the architecture, if the schema is right, things like that. So to cover all those aspects, we have a couple of programs. First we have something called Immersion Day. So it's a 2 to 6 hours program where we can specifically provide you the details of internal of service, how do you want to build certain things, and we also have labs, hands-on labs to build, covering multiple aspects of the building a service, right? So you can use that and get yourself familiar with the service. We also have a well-architecture review where we not only look at the service, but also look at the infrastructure like VPCs, things like that, to cover end-to-end the spectrum, including the security, deployment of the service, things like that. So we have a program like that. And we can also have a 1 or 2 hour design review sessions. And also we do have something called data labs where you know the service. I mean, you already did some kind of hands-on with the service, but you want to make sure your actual data structure or the application works. Then we can involve a data lab, and you can bring your own data and play with the service, right? Things like. So we have these different programs, and you can also reach us. Those are our aliases, email IDs. You can reach us with those. And if you want to get started, we do have a couple of webinars coming. There are certain things already there. So we do have a pretty good session coming in 20. We did a launch and also deep dive of the service in 2021 reInvent. You can watch the session. We do, feel free to scan the QR codes, and we have pretty good material for you guys to get started, and also labs. Yeah. So any questions? Like again, this is a chalk talk. Feel free to ask any questions, and also we can do a architectural overview to fit for your use case, right? We can do that. So we can open up for questions. Yeah, so the question is, can we use TTL to expire the data in the MemoryDB? And the answer is yes. Yeah, you can do that. It's since it's using Redis infrastructure, it's easy.
Yeah,
right.
So you use the same Redis data structures. I think the only difference would be you would have to use Redis in cluster mode. That's the only difference. But other than that, like you can use all the goodness that comes with Redis APIs.
Yeah. So it is fully compatible. If you're already using Redis application built on top of Redis, you can almost do a lift and shift. There are extreme use cases that we may have to do a second look, but almost in majority of the use cases, you can do lift and shift and use the service as is.
2 slides back.
Get to, okay. Okay, 2 slides back. This one? Oh, sorry.
Oh,
yes, okay. Yeah. So yeah, feel free to take pictures. You can send us an email, and also let me also show this last one. These, yeah. Oh, not this. Yeah, these are our email IDs. Feel free to message us. We can.
You can message us either directly or through the aliases. We have a lot of folks in there who will pay attention and can be available to you.
Mm-hmm. Okay, so the question is a very important question, good question, thanks for asking. So the question is, what is the difference between Elastic Cache and MemoryDB for Redis? So a lot of customers ask us. So let me also talk about similarities real quick. The similarities are both are in-memory databases, right? Like 100% of your data is in memory, and is in memory, right? And they both are Redis compatible services, right? And the main difference is if you're using Elastic Cache for Redis, it is more falls under cache category, right? You may have a permanent database. Predominantly, you're using that for durability of data, because when you're using Elastic Cache for Redis, there is a chance that primary may goes down, during which there is some data in transit to the replicas, and there is no guarantee that your data will be made into replicas, or there is chance of losing the data, right? So if you're
saying there is no transaction log to cache.
Yeah. So with Elastic Cache, the data is stored in the instance. I mean, in memory and maybe to the instance store for snapshots and so on. But it's not like if an entire region could go down as well. So it doesn't guarantee that the data never goes away. With the transaction log, it is durable.
Right.
So the MemoryDB brings that capability with the transaction log, right?
Yes. So yeah. So that is exactly correct. So that's kind of thing we say. We look at Elastic Cache as a cache service. You can put this in as a cache for all of the other databases, right? You can use RDS, you can use NoSQL, not everything like that. So this is a cache service. Elastic Cache for Redis also support cache across the regions. For example, we do have something called global data store. So we can do like an active passive cluster, and you can read from Elastic Cache from passive server as well. So we look that as caching solution, which you can use on any databases or even S3 things like that. Whereas in MemoryDB, we look MemoryDB as a primary database. So again, like I mentioned, you can do a lot more with it. It's a fully persistent, consistent, and fast database, right? A lot of customers use like the fastness and consistency, durability aspects of it. So we look that as a permanent database. And again, like I mentioned, there's a lot of benefits if you're using that for microservices. So we see that as a permanent database, a little bit more tailored to microservices, but you can also use MemoryDB because the caching aspect of it. A lot of customers also use it as a write-through buffer. For example, depending on different services, however you're using, some customer, for example, if there's an IoT use case, you want to store the data really, really fast. Like you're talking about like a couple of GBs or terabytes of data that's coming in. You may not need to store all of it all the time, but you need something to accept the write so fast. So I just showed you, it supports so much throughput, right? So a lot of customers also use this as a write through. So you insert the data into there, you read the latest data so fast, but you can also use the data after reading whatever the time frame you want to store it in, let's say, S3 or something else. So it's actually also falls under this multi-purpose data store use cases, but we are seeing lots of customers using it as a purely primary database. Just use it and then use it for everything. Yeah. Okay, so the question is for persistency, what is the service it uses? Like if you remember, I showed the multi-easy transaction log, right? So that itself is a service, right? That is inbuilt by us. It's our own proprietary service. It is a multi-easy within a region. So it has its own failure recovery. It has everything built within itself.
Yeah. So the multi-easy transaction log can store any amount of data, and definitely can handle writes in a durable fashion. So there's no memory limitations in how much it can handle and things like that. But usually you're limited by how much ever data you have in your in the nodes that you've picked.
Sorry?
That comes along with the MemoryDB cluster. So once you choose to have a MemoryDB cluster, you get a cluster endpoint. And just based on the cluster endpoint, everything else is provisioned according to it to support the service.
Yeah, the whole cluster is capable of storing up to 100 terabytes, right? So like I mentioned, because it also stores in the memory, right? That's the main aspect of it. So that's how you get super fast response time, right? So 100 terabytes on the cluster, but which means you are able to store up to 100 terabytes in the disk because you are using that for the whole cluster.
Yeah.
Right, yeah.
That's a good question. So there are broadly three aspects of the pricing. One is the nodes that you have chosen to have the writes into it or the reads from it. There's also a 20 cents per GB cost to handle the multi-easy transaction log and all the sort of like feature functionality that comes for it. There's also snapshots. If you're using the standard free tier snapshots, there's no additional cost, but if you need additional, there's cost for that as well. So there are these three aspects of the cost. I would highly encourage you to look at the pricing page. But but as a general sort of like an approximation, these are the three sort of categories you would look into.
Let me add something else on top of that. One reason a lot of customers actually adopting MemoryDB and loving so much is, like I mentioned, a lot of customers use underneath the database and cache, right? So they're using two systems. It's not only the maintenance part of it, but the cost aspect of it. You're paying two different services, things like that. So with MemoryDB, you can actually get rid of both. I'm saying more in terms of simplifying the architecture and use this. So when you compare two services versus one, you're actually saving a lot of money doing that. If you just look at MemoryDB, we have the pricing there. So, but because of the durability aspect of it, it is a slightly different cost model than Elastic Cache. But because again, it's a permanent database by itself. That's one thing. Let me also tell something else. Like we are aggressively coming up with a more RA model. It's coming up pretty soon. So with the RA model, just as a primer, you can actually kind of contracts where you can sign up for like 1 year or 3 year terms. With that, you see a lot of savings on top of all the discounts we're actually providing. No. Question?
What's recovery time if you have to spin up from a transaction
Right.
log?
What we are seeing, as per our regular tests and everything like that, we are seeing somewhere in ballpark of 3 seconds. But it can be a lot faster depending on other scenarios. But we want to be conservative in that. And 3 seconds is what.
Planned failure is around 200 milliseconds, but an unplanned failure is about 10 seconds.
Yeah, that's a good plan.
Approximately.
Yeah, planned and planned. Yeah.
And does this also have a global data store type of thing?
I mean, as a customer, if you're interested, please reach out and ask for more functionality. Yeah. But as of now, we don't have a global data store.
Yeah, I should add, we are aggressively collecting more data from the customers in those aspects. We actually want to delight customers in multiple ways because we are using Elastic Cache for many years. We know what the customers' patterns and what they're interested in. In some cases, we see asking for more. So we're asking a lot of customer questions, and we are coming up with a better and enhanced model for that, which we should be announcing pretty soon. As of now, we don't support though, but definitely that is something.
Please let us know if you have interest in such features as well.
As of today, yes, it's bound to a region, correct. So yeah.
Does it have full-featured querying like other database types?
Sorry?
Does it have full-featured querying like other database types? Does it have a query language too?
Yeah, so, okay, question is, does MemoryDB supports full-featured query language? And the answer to that is, as of today, we support only Redis APIs. So Redis is the predominant thing. Again, just like I mentioned, we are collecting more and more data feedback from customers. We're interested to come up with different options, but as of today, Redis.
Yeah, and we're still compatible with open source Redis from a cluster standpoint. I mean, as an application, whatever you're running on top of it, it's up to you. So 6.2.
Yeah, we had to correct it. So we support everything in 6.0. We also support few features in 6.2. So if you're using 6.0, definitely we're covering all of it.
Yeah.
So when 7 comes out,
Like all of our services, we're aggressively planning for.
There is a sort
upgrading.
of sort of list of features where we go.
Yeah.
It just sits in the queue.
So yeah, we are fully committed to serving the open source community. So all of our services will be upgraded to meet the open source community. That's actually in all of our services, right? Like in all of our AWS services, we are pretty much interested in supporting the open source community. So we're definitely adding that feature. So, any other questions? Yeah, like I said, feel free to send us an email. We are happy to help our customers in any way, fashion.